Hi, hello everyone. Welcome back to ANR Academy. This is Nepal Reddy sir, and today we are going to discuss rotation theorem or CONI method, which is from the topic complex numbers. Particularly the problems which are based on equilateral triangle, isosceles triangle, such type of questions in complex number can easily solve by rotation theorem or CONI method. Let us discuss today. Suppose that an organ plane assume that this is real axis and this one imaginary axis. Suppose that OZ1 is a vector. Suppose that makes an angle theta 1 with real axis. Angle made by OZ1 with real axis in the counterclockwise sense, suppose that theta 1. In case if the vector OZ1 that rotates through an angle alpha, and suppose that reaches to the point Z2. Rotating OZ1 through an angle alpha, OZ1 changes to OZ2. This is the rotation, and here the angle of rotation, suppose that some alpha, and assume that OZ2 that makes an angle theta 2 with real axis in the counterclockwise sense. This is theta 2 and first one making an angle theta 1, and the angle between OZ1 OZ2 here alpha. Then by rotation theorem I can write this relation. Rotation theorem says that OZ2 divided by OZ1 equal to modulus OZ2 divided by modulus OZ1 e power iota alpha. This is the result by CONI method or rotation theorem. Let us see the proof of this. Here you have OZ1. OZ1 that is a vector. Clearly in the figure it makes an angle theta 1 with real axis, so that I can write modulus OZ1 e power I theta 1, and this is the result by Euler form. By Euler form, complex number z that can be written as mod z into e power I theta, where theta is angle made by OZ with real axis in the counterclockwise sense. So by Euler form, OZ1 can be written as modulus of OZ1 multiplied by e power I theta 1. In the same way, OZ2 I am going to write modulus of OZ2, it is e power I theta 2. This is second result. Now OZ2 by OZ1 I am going to write. When OZ1 rotates an angle alpha and after that the final position OZ2, these two lengths are same, so that OZ1 OZ2 equal, assume that they are some r. This is r into e power I theta 1, second one r into e power I theta 2. On division, these two lengths are equal, So they get cancelled and we get e power I theta 2 divided by e power I theta 1. Whenever these two are of same length, these two gets cancelled. OZ1 by OZ2 gives e power I theta 2 by e power I theta 1. Therefore, it is e power I theta 2 minus theta 1, that is e power I alpha. Observe the figure. From the entire angle theta 2, if you remove theta 1, you will get the angle alpha. So that you got the result OZ2 by OZ1 equal to e power I alpha. Also, you can write OZ2 equal to OZ1 e power I alpha whenever OZ1, OZ2 are of same length. Remember that here the condition modulus OZ1 equal to modulus OZ2. In this case, you can write this relation. Next, suppose that OZ1, OZ2 are of different length, then what happens? Observe. Again, it is real axis. Origin, and this one imaginary axis. Suppose that OZ1, OZ2 are of different lengths. If OZ1 makes an angle theta 1 with real axis, OZ2 makes an angle theta 2 with real axis, and suppose the angle between OZ1, OZ2, if it is alpha, then let us discuss the relation by CONI method. OZ1 that making an angle theta 1, so that OZ1 by Euler form modulus of OZ1 e power I theta 1. Next I am going to write OZ2. Its length modulus OZ2 e power I theta 2 it is. Complex number Z can be written as R into e power I theta by Euler form. So that OZ1, OZ2 written in this way. Now, OZ2 divided by OZ1, if you write, what happens? This is modulus OZ2 e power I theta 2 divided by modulus OZ1 e power I theta 1. And OZ1, OZ2 are of different lengths. This is large and this is smaller. So, you have to write modulus OZ2 and modulus OZ1 as it is. And in the next step, you will get OZ2 divided by modulus OZ2 value, that become OZ1 divided by modulus OZ1 e power iota e power I theta 2 divided by e power I theta 1, that is e power I theta 2 minus theta 1. And the difference between the two angles theta 2, theta 1, from this figure it is very clear that that is alpha. So that I can write theta 2 minus theta 1, this angle as alpha in the next step. Therefore, unit vector in the final position OZ2. OZ2 is the final position after rotating through an angle alpha. So, final unit vector equal to, why it is unit vector? Due to dividing with its modulus, you can say that it is a unit vector. Final unit vector equal to initial unit vector multiplied by e power iota into angle between them, I alpha. So in this way you can easily remember rotation theorem. If OZ1 rotates through an angle alpha and Z2 is different, OZ2 is of different length compared to OZ1, in this case it is very simple to remember this result. Final result with unit vector equal to initial OZ1 unit vector, here you have, and it is multiplied by e power I alpha. Next, suppose that if there are Z1, Z2, Z3, 3 points, Z1 here, suppose Z2 here, and somewhere it is Z3, and the angle between them suppose alpha. OZ, Z1, Z2 is initial one, Z1, Z3 is final one. This is initial vector, and this is final vector after rotation. Just now we discussed in the organ plane, you can write the relation by CONI method. Final unit vector equal to initial unit vector multiplied by e power iota angle between them, that is e power I alpha. Final unit vector here, after rotation Z1, Z3, initially you have the vector Z1, Z2. Unit vector of Z1, Z3. Z1, Z3 vector written as Z3 minus Z1. To get unit vector, you have to divide with its magnitude. So Z3 minus Z1 by mod Z3 minus Z1 in the left hand side, it is equal to, next in the right hand side, initial vector for which unit vector you have to write, that is Z2 minus Z1 divided by modulus Z2 minus Z1, it is multiplied by e power I alpha. This is the result whenever Z1, Z2, Z3 are 3 points and the vectors Z1, Z2 suppose rotated through an angle alpha and reaches Z1, Z3, then this is the relation. And suppose that if Z1, Z2, Z3 and Z4, 4 points, suppose this is Z1, somewhere here Z3, assume that here it is Z2, and suppose that this is Z4. Suppose the rotation, angle of rotation in the counterclockwise sense, suppose alpha. Here Z4 minus Z2, this is initial vector, and Z4 minus Z2, next Z1 minus Z3. After rotation it is final vector. Since alpha is angle of rotation, by CONI method I can write the result. First, final unit vector, that can be written as initial unit vector multiplied by e power I alpha. Final unit vector, that is Z1 minus Z3 divided by modulus Z1 minus Z3. It is equal to initial unit vector Z4 minus Z2 divided by modulus Z4 minus Z2 e power I alpha. So this is the result by rotation theorem. On problem solving, like the problems based on equilateral triangle, or isosceles triangle. Such type of models in the complex numbers can easily solve by this rotation theorem. Let us discuss one question. Suppose that the question is Z1, Z2, Z3 are 3 points. Z1, Z2, Z3 are 3 points. And they are vertices of an equilateral triangle. Then first result, Z1, Z2, Z3, they are vertices of an equilateral triangle. Then prove that Z1 square plus Z2 square plus Z3 square equal to Z1, Z2 plus Z2, Z3 plus Z3, Z1. And the second result, Z1 minus Z2 whole square plus Z2 minus Z3 whole square plus Z3 minus Z1 whole square equal to 0, and 1 by Z1 minus Z2 plus 1 by Z2 minus Z3 plus 1 by Z3 minus Z1, it is equal to 0. Suppose this is the question. Let us see the proof by rotation theorem. You have to prove these three results. Given Z1, Z2, Z3, they are vertices of an equilateral triangle. Let us draw first an equilateral triangle. Suppose that this is Z1 and it is Z2, this one Z3. Here the angle of rotation 60 degrees. Why? Because it is an equilateral triangle. Z1, Z2 is initial vector. After rotating 60 degrees in the counterclockwise sense, here you have another vector Z1, Z3. Therefore, by rotation theorem or by CONI's method, final unit vector, that is Z3 minus Z1 divided by mod Z3 minus Z1, it is equal to initial unit vector, this one, Z2 minus Z1 divided by modulus Z2 minus Z1 e power I, theta value here 60 degrees, angle of rotation 60 degrees, so that e power I pi by 3 we have to write. And clearly these are of same length due to an equilateral triangle. So these two gets cancelled and we get Z3 minus Z1 equal to Z2 minus Z1 multiplied by e power I theta, nothing but cos theta plus I sin theta, cos pi by 3 value, cos 60 degrees 1 by 2 plus I sin 60 degrees value, that is root 3 divided by 2. Now apply square on both the sides. What happens? Observe. First Z3 minus Z1 divided by Z2 minus Z1 I am going to write, and in the right part it is 1 plus I root 3 whole divided by 2 and cross multiply it. Left hand side 2 times of Z3 minus Z1. On cross multiplication it is. Next in the right hand side 1 plus I root 3 multiplied by Z2 minus Z1. 1 plus I root 3 multiplied by Z2 minus Z1 it is. Now apply square on both the sides. We get 4 multiplied by Z3 square plus Z1 square minus 2 Z1 Z3, which is equal to 1 plus I root 3 whole square value, that is A square value, or otherwise do one thing, this is 2 times of Z3 minus Z1 and it is Z2 minus Z1 plus I root 3 multiplied by Z2 minus Z1. Transfer the first term into left part, 2 times of Z3 minus 2 times of Z1, next this one minus Z2 plus Z1 gives the result iota root 3 Z2 minus Z1 it is. And now on simplification it become 2 times of Z3 minus Z1 minus Z2 gives the result iota root 3 multiplied by Z2 minus Z1. Now apply square on both the sides. Two times of Z3 minus Z1 minus Z2 whole square equal to iota square value minus 1, root 3 whole square value 3, Z2 minus Z1 whole square value Z2 square plus Z1 square minus 2 Z1 Z2. Now if you simplify this, 4 times of Z3 square plus Z1 square plus Z2 square, next minus 4 Z1 Z3, next plus 2 times of Z1 Z2, next minus 4 times of Z2 Z3, next transfer right terms into the left part, you will get plus 3 Z2 square plus 3 Z1 square plus 6 Z1 Z2, it is equal to 0. Now if you simplify this, what we get, observe, Z1 square plus Z2 square, there are 4 times Z1 square plus Z2 square plus Z3 square. Actually we need to prove this result. Left hand side you have sum of squares of Z1 Z2 Z3, you got 4 times. Remaining terms I am going to write in the right part, and here Z1 Z3 4 times and Z1 Z2, there you have to write negative sign. Why? Because this is product positive, taking into left side you get negative sign. So minus 4 Z1 Z2 from these two, next minus 4 Z2 Z3 minus 4 Z1 Z3 you have. So taking into right part 4 times of Z1 Z2 plus Z2 Z3 plus Z3 Z1, we get 4 gets cancelled, hence you got the result. So this is the first result, Z1 square plus Z2 square plus Z3 square equal to Z1 Z2 plus Z2 Z3 plus Z3 Z1. Okay. So in this way you can prove the result. Next, let us prove the second result. Here the second result, you have z1 minus z2 whole square plus z2 minus z3 whole square plus z3 minus z1 whole square you have. What I am doing, observe, very simple. With the help of first result, just multiply 2 on both the sides. What we get? 2 times of z1 square plus 2 times of z2 square plus 2 times of z3 square minus 2 times of z1 z2 minus 2 times of z2 z3 minus 2 times of z3 z1 equal to 0 we can write. Just multiply 2 on both the sides and written in this way. It can be written as z1 square plus z2 square minus 2 z1 z2 one result. Next plus z2 square plus z3 square minus 2 z2 z3 second result, and z3 square plus z1 square minus 2 z1 z3 equal to 0. So you can write perfect square this one as z1 minus z2 whole square plus z2 minus z3 whole square plus z3 minus z1 whole square equal to 0. You got the second result, this one. Next we have to prove the third result. To prove the third one, what I am doing, observe, you know that this is an equilateral triangle, and assume that each side is of length small a, small b, small c, and z1 minus z2, suppose that is a vector, this is a vector, this is b vector, and this one c vector. You know that a plus b plus c whole square, that can be written as you know that a plus b plus c whole square value a square plus b square plus c square plus 2 times of ab plus bc plus ca. Here a is nothing but z2 minus z1 or z1 minus z2. Suppose that small a, which is equal to, I am going to select this one as z1 minus z2, small b z2 minus z3, small c z3 minus z1. Okay, z1 minus z2, z2 minus z3, final z2. Okay, c z3 minus z1, final z3. Assume that a bar, b bar, c bar, three vectors. Notation z1 minus z2, z2 minus z3, z3 minus z1. See, a plus b plus c, what happens on adding all these, we will get 0. So 0 square equal to, next a square is nothing but z1 minus z2 whole square, b square nothing but z2 minus z3 whole square, c square z3 minus z1 whole square. So you have second result 0, so that this one written as 0. Next plus 2 times of AB plus BC plus CA we get, and from this I can write AB plus BC plus CA equal to 0. Divide each and every term with ABC. First, second, third, 3 terms I am going to divide with ABC, and in the right part when you divide it is 0 itself, right? Now simplify this. What happens? You will get 1 by a plus 1 by b plus 1 by c equal to 0. Our assumption A, B, C clearly A is nothing but Z1 minus Z2, B is nothing but Z2 minus Z3, and C is nothing but Z3 minus Z1, and hence the third result also true from this. So the problems from the complex numbers topic, particularly the problems like based on equilateral triangle, isosceles triangle, that is the angle the question related with angle between two lines, they can easily solve with the help of CONI method or rotation theorem in this way. Thank you so much. I hope you understand everything. If you like this video, please like, share and subscribe my channel. Thank you very much.